Howdy. Today we're going to look at another way to write numbers, and this way is called scientific notation. Scientific notation is used when you're trying to write really large or really small numbers, and scientific notation is always written in this form: a times 10 to the power of n, where a is something called the coefficient, and a coefficient is just another way of saying a number that you multiply. And our coefficient always has to be greater than 1 but less than 10. So a good way to think of it is just that it's between 1 and 10. The 10, just like with our place value system, is our base. And the n, right there, is an exponent. And you might also hear it called an exponent as an integer, and the exponents can be positive or they could be negative, depending on the size of the number. So these are some things that are really important that you need to know. The a is the coefficient, the base is 10, and it's always base 10 for scientific notation, and finally the n is the exponent. So here we have a really big number that we're going to put now into scientific notation. And this number is read in words as 5,346,000. The first thing I want to do is create that coefficient between 1 and 10. So what I'm going to do is find my decimal point. And my decimal point in this number is right here at the end, even though you can't see it. So what I'm going to do is mark down with a pen here the decimal point. So what I want to do is move that decimal point to the spot where I can create my coefficients. So what I'm going to do is I'm going to move that decimal between the 5 and the 3, which is right there. So use my pen and I'm going to move right to there. And I'm going to get rid of all the unnecessary zeros. And there's my coefficient. So it's going to be 5.346. And it satisfies the conditions. Is it between 1 and 10? Yes, it is. Like I said before, my base is always 10, so I can write that in. And now what I want to do is find the value of the exponent, and that's pretty easy. If I go back to where my coefficient is, right there, the decimal, and I move to the end of the number, however many places I need to move will give me that coefficient. So I go 1, 2, 3, 4, 5, 6. It moves 6 places. So that means that my exponent value is 6. And when I think about it, that makes sense, because I think about 10 to the power of 6. That is equal to 10 times itself 6 times. And when I multiply it out, that gives me 1 million. So if I do some estimating here, and I think, well, 5 times a million gives me close to 5 million. Actually, it gives me 5 million. Then the 5,346,000 sounds pretty decent. The other thing that I can do now is turn a number in scientific notation back into standard form. So here I have 4.27 times 10 to the power of 5. So because it's a positive exponent, I know right away that this number is going to be bigger than 1. It's not going to be a decimal. So what I'm going to do is I'm going to rewrite my 4.27 here. And because it's a bigger number than 1, I'm going to be moving to the right the amount of times that the exponent tells me to, in this case 5. So what I'm going to do now is just move that decimal point over. Use a different color here to help illustrate that. So I'm moving it 1, 2, 3, 4, 5. So now my decimal is going to be at the end of this larger number. You're going to notice here that I got some empty spots. I got an empty one there, there, there. I got these 3 empty cups. And what I'm going to do is I'm going to fill those with placeholders or zeros. So they're going to fill up like that. So when I remove those decimals, I end up with 427,000. Once again, I can check this for reasonableness because if I go back up here and examine 10 to the power of 5, 10 to the power of 5 is equal to 10 times itself 5 times, which is 100,000. And 100,000 times 4 is 400,000. So 4.27 times 10 to the power of 5 should equal 427,000. And here's one last example where I can turn a smaller number than 1 into something in scientific notation. So here I have 28 10,000ths, which is a pretty tiny number. It's a lot less than 1. But I'm going to put it into scientific notation now, and it follows the exact same rules, except now I'm going to end up with a negative exponent, not a positive exponent. So again, my coefficient has to be somewhere between 1 and 10. So my decimal now is going to move from where it is over in between the 2 and the 8, which is right there. So my new coefficient is going to be 2.8. Again, it's still base 10. And if you notice, the amount of times I need to move it is 1, 2, 3. So my exponent value now this time is going to be -3. So the correct answer now is 2.8 times 10 to the power of -3. So hopefully that will help you understand scientific notation a little bit better, and we'll talk to you again soon.